In the last video we were looking at if a relationship was proportional, and the way we check to see if a relationship was proportional, if you remember, is to put all the y values over their corresponding x values and see if they each were in the same ratio. So in this case we would put 1.5 over 2, and is that equal to 3 over 2.25? I started to make one of those common mistakes, which is to put the x over the y, which is an easy thing to do because the ordered pairs are x and then y, but when we're checking for proportionality, we put the y over the x. So 2.25 over 3. And is that equal to 3.75 over 5? And if we divide each one of these out, 1.5 divided by 2 is 0.75. And 2.25 divided by 3 is 0.75. And that's equal so far. And then is 3.75 divided by 5, and that is also 0.75. So then we asked about the constant ratio, and I said, well, these are all decimals, and that lets me know that this relationship is proportional, but what is the constant ratio? Well, hopefully very easily we can see that 0.75 is 3/4, and that is our constant ratio. Today we're going to call that constant ratio the constant of proportionality. So this constant of proportionality is, well, it has a symbol, K, and it is the ratio if a relationship is proportional. So the way we find the constant of proportionality is by dividing all the y values by their corresponding x values, and if they are all equal to each other, the relationship is proportional, and the constant of proportionality is that ratio, or 3/4. So in this case, we would say K equals 3/4. Now, is it okay to write it as a decimal? Well, in certain circumstances. Because another thing that today's assignment is going to ask you to do is not only find the constant of proportionality if a relationship is proportional, but then write the equation. Well, we can very easily turn this equation, or this equation, because it is an equation with equal sign, into an equation that's a little bit more, nice looking. And that is if we multiply both sides by x. So if k equals y over x, we get rid of the division of x by multiplying both sides by x. And so that is kx equals y, or more commonly it's written as y equals kx. And hopefully you can see that this equation is equivalent to this equation. It's just that we normally find the ratio of proportionality using k equals y over x, and then once we find it, we write the equation using this form. So if I were now going to write the equation for the number of hours it's been raining compared to how many inches have accumulated, if it's raining consistently, then y equals 3/4 x, or for every hour 3/4 of an inch accumulates. It would still be okay to write the equation as y equals 0.75x. Both of those are correct. Equations. Now let's look at another example. So let's say that you have this little boat that you've made, and you decide to float it down the gutter, I don't know, and it's traveling at a certain rate. After 5 seconds it's covered 3 feet, and after 8, 4.8 feet. After 12 seconds, 7.2, and after 20, 12 feet. So the first question is this relationship proportional? And if so, state the constant of proportionality. So we need to set up those ratios. Of course, remembering that To find the constant of proportionality, we see if all the y values over their corresponding x values are equal. And if you simplify each one of these, they all equal, if you just divide the top by the bottom, 0.6. So we know that the relationship is proportional. And the constant of proportionality is 0.6. Or, if we want that in fraction form, 6/10 as a decimal is 6/10 as a fraction, and then you can simplify it to 3/5. So, in general, I prefer the fraction, but the decimal is correct too. So, if we also want to write our equation, remember that we go back to y equals kx, which is still this equation, just rearranged. But we can now plug in the k value, so either y equals 0.6x or y equals 3/5 x. And either one of those is an acceptable equation. In fact, officially, 3:5 as y is to x is also acceptable. It's just not as pretty. It's not as commonly used. Now, some other things you might be asked to do are to define variables for the quantities that are changing. Well, in this situation, how many seconds the boat is floating along changes, and how many feet it travels continues to change. Well, in general, we just use x and y. The x is the independent, and the y is the dependent. The x is the known. We know how many seconds it's been traveling. What we don't know is how far it has traveled. So its distance depends on how long you allow it to continue to travel. So you can use those, and so it's perfectly acceptable to say x equals the number of seconds, or the time in seconds, and y is the distance in feet. But it's not incorrect if you were to use other variables like t. Let's see what I'd get a different color here. If we wanted to say, okay, seconds is t because that's time, and d for distance, you could do all that. But personally, I just prefer to stick with the x and y because that helps me if I have to graph it, and I don't have to reevaluate. Well, is t the x or is d the x? I don't know. Something else that you might be asked is to explain what the constant of proportionality means in this situation. So again, whether we're doing 0.6 or whether we're doing 3:5, you choose which one it is and explain it. Well, the 0.6 is, and if you'll remember, that this equals y over x, and the y is distance or feet, and the x is time in seconds. Well, this is really the key right here to helping you understand what the constant is, because the constant is 0.6 feet per second. That's what the constant means. That little boat is traveling at 0.6 feet per second. You could also say that the boat is traveling 3 feet every 5 seconds. And of course I get that from the fraction 3/5. Or you could even say 3/5 of a foot per second, which is what 0.6 feet per second means. And now the thing is that you could use this equation to predict how far is it going to go if you were to allow it to travel for a full minute. Well, that's time, so that's x. So y equals 0.6 times 60, which turns out to be 36 feet. So it can travel, if it keeps up the same rate, 36 feet in 60 seconds. You could also turn it around and find out how many seconds it would take for it to go, say 48 feet. So 48 feet equals 0.6x divide both sides by 0.6, and that would be 80 seconds. I'm running out of room here.